So we're going to talk today about the base angles theorem. The base angles theorem says that when you have congruent sides of a triangle, the angles opposite those sides are going to be congruent. So here we have an isosceles triangle, and because those two sides are congruent, we call them legs. These are our base angles. And they're marked congruent because they're across from these legs. So that's how that theorem works, okay? Here's, it's just rewritten in a different way. This is the theorem itself, talking about how, again, angles B and C in this case are going to be congruent because they're opposite those congruent sides. But we also have the converse of the base angles theorem. Remember, that's the backwards, the opposite. So if you know that angles B and C are congruent, you're also going to know that those segments AB and AC are congruent as well. So we can also take this one step further and talk about equilateral triangles. The thing to know about equilateral triangles is that because all three sides are the same, that means they're equilateral, that all three angles are going to be congruent as well, because every angle in the triangle is going to be opposite congruent side. So the big takeaway is that when you have multiple sides of a triangle that are congruent, so this would be two or more, the opposite angles are going to be congruent as well. So in this equilateral triangle, all of the angles are the same. Don't get ahead of yourself though. This right triangle, we know that one angle is 90 degrees. It's always opposite the hypotenuse, the longest side. But that's all we know. This other angle, we have no information about what its measurement is going to be based on the information we have. So you can't use the base angle theorem for triangles that don't have at least two congruent sides. We're going to look at an example. We have an isosceles triangle. We're given that this angle is 75 degrees. So we're automatically going to know that our other base angle is 75 degrees too. Don't let the fact that the triangle's been flipped on its side confuse you. You're looking at those congruent sides, and that helps you figure out what to do. So we know now that y is 75. And those aren't my hands, by the way. But when we now are going to solve for x, we have one angle left to find. Remember that triangle angles, the three of them, always add up to 180 total. So if we combine like terms here, that gives us 150 plus x equals 180, and then we'd solve and find that x equals 30. Here we have a problem that's going to ask us to use our knowledge of the exterior angle theorem as well as our new knowledge about the base angle theorem. You can see again that we have an isosceles triangle, so we can go ahead and say that both of these angles are congruent because they're opposite those congruent legs. And we can use that knowledge to solve for that exterior angle. Okay, so here we go. You can see that the angle that's given to us is 24. Okay, so we just need to say that x plus 24 is 180. If we, again, combine like terms, we're going to have 24 plus 2x equals 180. Subtract 24. You're going to be left with 2x equals 156. Then you're going to divide by 2 and find that your x value is 78. So you can take that 78, you now know the value of x, so you now know the measure of these two angles. So we're going to go ahead and write down 78 degrees on both. And now we have two ways to solve for y. One is, because it's on a line, we know that 78 and y make a linear pair. So one way to solve for that would just be to say 180 minus 78. The other way would be to use the exterior angle theorem and say that 78 plus 24 is going to equal y. And so either way, you're going to find that y equals 102 And so that's a few things you can do knowing the base angle theorem, working with isosceles and equilateral triangles.